Hello, everyone. Today we will present you our mechanical engineering design project, Scootsafe. I am Beril and my team members are Burak and Yiğit. We are aiming to contribute to the ongoing transition to scooter travel that has accelerated. Society no longer wants to use public transport due to health concerns. This has necessitated the public to look for other forms of travel, namely electrical scooters. They are foldable and lighter and transportable. However, there is a massive safety issue that needs to be attended, considering that electrical scooters offer no protection against bigger vehicles, such as motorcycles and cars, and they are no longer eligible to use on the sidewalks. So any sort of impact between a car and a scooter would result in massive damage for the latter side. We have designed and manufactured a crash bar specifically for scooter car and scooter motorcycle interactions. Here's our designs, which consists of two parts, the crash bar itself and the attachment. The attachment is detachable, so the whole part can be detached from the scooter. The crash bar and attachment together weighs 3 kilograms, and the crash bar itself weighs 2 kilograms. In order to further investigate the effects of our design, we have done some ANSYS tests and calculations. According to our calculations, the maximum force that our crash bar can take is 3,750 newtons. This force means that a car with a mass of 1.5 tons can hit our crash bar with 25.85 kilometers per hour, and our crash bar will take it. Also, we have decided to manufacture our design with stainless steel, which has a yield strength of 290 megapascals.
This is the ANSYS test results, and we applied the statical structural ANSYS test. As you can see, the purple area, nodal force applied area, you can pass. And this is the total deformation test for the applied force, what we calculated in before slides. As you can see, the maximum deformation is the 7.9 centimeter on the red zone. On the equivalent stress results, as you can see, the red zone on the below side, 260 megapascal. This is also below the yield stress of the stainless steel. This is the second ANSYS test. We applied the different force. As you can see, the total deformation for this force, 3.2 centimeter for this red zone. This is the equivalent stress for the second force. As you can see, the below red zone is a critical part for this force.
So for prototypes, we were able to manufacture all two parts individually. So here is the prototype for the crash bar. We basically heated the pipe and bent it with hammer, and we used water to cool it down. And for the attachment part, we were able to successfully manufacture a fully functional attachment part. As you can see on the left side, the crash bar basically you put in the crash bar and it's fully functional. So for manufacturing, so first of all, we realized that we went to Zeytinburnu and we were told that we need very precise dimensions in order to manufacture anything here. So we started working with Legos, and we used Patafix to resemble welding. After we designed and came up with the dimensions, we basically found a metal shop and handed them the dimensions you can see on the screen. And then Hasan abi started wired argon welding for stainless steel. We basically were able to complete half of our manufacturing on the first day for the attachment part. And here you can see we again used water to cool it down. And so moving on, the welded parts didn't look beautiful because there were a lot of factors of error. It basically messed up all the angles and it didn't look beautiful. So we used stainless steel spray. It both strengthened the welded areas and it gave our part like a shining, nice glaze. And on the second day, we basically implemented the part that is supposed to hold the crash bar. And we used rubber to prevent the part from hurting the from damaging the scooter. And on the right, on the bottom right, you can see all of our parts dismantled, our assembly. We basically used 3 metric 4 bolts and fiber nuts to prevent from any sort of slipping in impact. And that's it. Thank you for listening.